There we go. Now I got the record on for him. Okay, so in my CNC mill files folder, I'm going to create a new directory. I'm going to call it my lesson 7. And we're going to call this circular exercises. Then I'll hit OK. You should see that file or folder appear down here. We'll select that, and then my file name, I'm going to highlight the no name 1 and leave the .fnc, and I'm going to name it first initial last name lesson 7, lesson 7, and we'll call this exercise number 1. There's a few exercises we'll do here in lesson 7, then we're going to jump right into lesson 8. And lesson 9, we're going to flow through these pretty quick because I want to get to cutter comp. Okay, get the final touches on our mill programming. So once I've got that, I'll hit save, and there we go. The midterm, I've got to go through and I've got to transfer the paper copy gradebook over to the Blackboard. If you haven't seen that yet, everybody did really well in their programming midterm. I didn't have any that were just absolute. I mean, we're talking a couple points here and there, several perfects. Everybody did a really good job of using their resources, like I've been trying to tell you to do. So, and I'll get that up and I'll let y'all know whenever that's there. You'll be able to see it on there. But pretty happy with the way the midterms went. Okay, so that being said, let's go up here to lesson 6. I'm just going to double click on it. I'm going to take the percent sign all the way down to the tool 4 because we're going to use that 1/2 inch end mill. I'm going to copy all of that. And we'll go back to our other program and double click it and paste all that in. Give me a little spacing below and start doing my modifying. Program number first. Once I've got that, we're going to change that to 701. Lesson 7. Exercise number 1. Circular milling. A few of you slept too many days between the midterm and today and really bombed those G&M code quizzes. Let's get to studying those again. Okay, if you're struggling with those, need to get on top of that for this next 8-week run. I've got countdown. I'm in countdown mode when we get to this time of year. Instead of putting what week we're in, I tell you how many weeks we got left. After today, we've got 7 weeks and 1 day left. Okay, 2 days a week. So basically, we've got 15 days together. All right, so 15 more G&M code quizzes. So keep that in mind. All right. Okay. Safety line looks good. Plane, inch, cutter comp cancel, tool length cancel can cycles, return to reference, sending that Z home for a safe Z return. Everything looks good there. Stock material, we'll put in our size that we just set it at, just for good measure. We're going to set the origin on the left front corner of the part, and then we're going to adjust X offset positive 125 thou, because that's what we would do at the machine. That's what I was talking about in the reference point when we set up the stock at 2 3/4, 2 1/4. We move the reference location negative because in the draw screen you have to move the part, not the origin. At the machine, we're moving the origin, so we're going the other direction. All right. And I'll come down here and my type of comment, because what we're going to do is middle of the contour with radius cuts. We're going to go back to our other program and I'll go ahead and save what we've got there. And from this program, we will come down and we're going to take the tool 4, basically from the T4 all the way down to the coolant on line. Let's just take all of this right here. We'll copy that. Okay. Go back to the other program, we'll paste it in, and we'll verify it. Tool 4, T4M6. T4M6. Got a Tool 4 activate tool change. Looks good there. Got our comment. We got our op stop to verify it. Then we're moving to our start position. Let's start down off the bottom left front corner of the part. So we'll start out at X minus 0.5, Y minus 0.5. Okay, that'll get us down off the bottom corner of the part. Come down, tool length compensation with our H4. Feeding down to the linear feed rate of 50 inches a minute to 2 inches above. We're going to pause there and check our tool length. And then we'll turn the spindle on once we've verified the length's good. And then we're going to go to a depth of 125 thou deep. All right, big guy? Okay. All right. We're going to move over. Basically, we're going to move over now to mill straight up this first wall. So if this wall is at X0, we got to move over to X minus 0.25. So that's our first move, X minus 0.25. Because we don't want to, well, I mean, you could, I guess. We're just plunging down off the bottom corner of the part. Okay. Then we're going to, what's that?
Don't we need a feed rate there?
Yeah, we can set it to it. We can set it here if you want. We can set the feed rate at 91 here.
I guess you're going to put it on the next line, weren't you?
Yeah. It's okay. They can go there. Then we're going to feed up the part to the start of the radius right here. So basically, if this is 2 inches up to here, the radius is a 1/2 inch, so we're basically a 1/2 inch down from the 2 inches, so we're going up to Y 1.5. I'm just going to call that my position 1. If I was plotting the points on this part, that's how I would do it. I'd call that my first position and then go from there. Kind of cheating. I always tell you to plot your points before you start. Okay. All right. Now we're going to do our next move. I just realized that this is all on your page, isn't it? I was getting ready to tell you to plot all the points, but it's giving them all to you. We're going to do our next move. So we're doing a G2, the direction. So G2, we're going over to X.5 and up to Y 2.25, the 2 inches plus the tool radius. And then the radius value, we're going to use an R here. The radius value would be, since it's on the outside, the 0.5 plus the tool radius. So it would be an R.75. Or you could use an I.75 to get the same results. Either one could be used there. The R is easier because the R can be used just, you don't have to think about whether it's positive or negative or whether it's an I or a J. It doesn't matter. It can be used universally whenever the machine supports it. The I or the J would be based on X or a Y direction, or in some cases both. Some cases you might be starting an arc. Let's say you're doing a partial fillet. Let's say you came straight up and then you're only going to like right here with the fillet. Okay. In that case, you'd have to trig it out and you'd have to figure out what the I and the J would be. Okay, I've got some extra practice parts that we'll do that actually have that on it, where we have to do a little bit of trig with our calculators and figure out what those I's and J's are. Okay, so that looks good. If we draw this now, that's what we're looking at. Okay, let's make sure everybody's made it to this point. Look all right? Okay, so biggest, most common thing I see when we start using radiuses. The biggest issue people run into is this right here. We're going to move to the next point. Okay, we're going to move to this next point over to here, which is at X 2.5 plus the tool radius, so 2.75. So X 2.75. All right. Then you draw it. And you get this error. Specified radius is too small. Jump to error block. Okay. I hit yes. Okay, see where the cursor's at, right? Some of you I can tell already know what's wrong, but here's what happens when you run into this. You saw the word radius in your brain, you saw the word radius in that error message. So by habit, by just pure human nature, you start looking at the G2 line. Okay, everybody does it. Every time, almost 99% of the time, when somebody says, hey, I'm getting this error message, they call me over there and they tell me, I've looked at my points, they look good, my radius is correct, everything looks good in this line. And I promise you, 9 out of 10 times, I have to say it's because you forgot to put a G1 here. Once you do a G2, it's modal until you tell it otherwise to go back to a straight line move. Okay, and that's where that error, if you see that error message 9 out of 10 times, it's because of that, not because you messed something up here. Now, you could have messed up your points here, that 1 out of 10 times, but most of the time it's because you forgot that. So I always tell everybody, make sure if you see that error, you make sure you have your G1 in that next line. Because like right here, let's say I did mess up those points. I've got my G1, let's say I messed this point up and I put a 5 here. I got my decimal in the wrong spot. Well, I get the same message. It's going to jump to that line. And then I start looking at that line. Pay attention to where the cursor goes. Whatever line that cursor goes to, that's where it's running into the error at. That's a Herco thing. That's a WinMax thing. You don't get that. Most of the time when you get error messages in a program, it doesn't even give you a sniff of where it's at. The Herco control is pretty nice of taking you right to that line. so let it help you out and help you decipher where it is. All right. So now we're going to come down the part, down to right here to the top of this radius. So if this is 0 at the bottom of the part, that radius is a 1/4 inch, so we're coming down to y 1/4 inch. So I'm at the start of that radius now, right here. And we're going clockwise again, so we're doing another G2. The X and Y endpoints. So the X value would be 2.5 minus the 1/4, so X 2 1/4. Y, if this is 0 right here, we got to go down the tool radius, so Y negative 1/4 inch with an R 0.25. Or, oh yeah, plus my tool radius. Let's leave that there for a second, just so. I minus 0.5. If I draw that right there, it's a great example of me not doing my math right. Specified radius is too small. Okay, then I look at it and I say, oh, I forgot to add my tool radius to my value. That's supposed to be 0.5. I don't know why my errors keep popping up on my other screen, but so there is the part. Now I just got to do a G1 back to X minus 0.5, exit the part. Okay. And then I'm ready to finish out this program. Okay. Now, I had multiple, and I don't remember if it was this class or the other class, but I had multiple people when I graded the midterms that they got to the very end of the program and everything looked really good, you know, small little things, but then at the end of the program they got the last part done and just stopped right there. Now you got to understand, we have to send everything home and shut everything off at the end of the program. Otherwise the machine will just sit there with the spindle running and the coolant running over the top of the hole or wherever it's at until you tell it to go home or manually do it. So we have to close the program. So there were a few, I took a couple points away where people got in a hurry and they didn't put in their into program blocks here. Okay, from the G0 to 2 inches above and shutting off the coolant to the percent sign. Got to make sure we put those at the end of the program. Okay. And there's that part finished up, milling around it. All right. What I want you to do, okay, I want you to take what we've done here, same concept, okay, we made the part a 1/4 inch bigger both ways, and then we shifted it over 125 so that it mills all the way around it. I would like you to go in and write you a program. Take what we just did and write a program to go around this part. Now you're going to have to make the block a little bigger, 2.5 square, so 2.5 by 2.5, or we made it a 1/4 inch bigger, right? So 2 3/4 by 2 3/4. And then do the same thing, but this time come down here and you're going to mill around the inside, and you can just plunge at any of those locations that you want to. You can plunge down and make a counterclockwise slot milling around the inside of this. Okay, it should have an 1/8 inch outside wall basically on the outsides here. Okay, so write you an exercise 2 program for this one. Make this one exercise 2. Make this one exercise 3. Okay. I need you to do those 2. We will, when we get back in here, we will do this together. We'll do this one together, and then we'll jump to the next exercise together, okay?
How big did you say to make the stock? What size?
2 3/4 by 2 3/4. It's giving you the programs here, guys. So I just want you to put it all together and see how it works. Okay. Now, you can do that right now, or you can work on this workbook page, page 70. This is to get completed, and all of it gets submitted on the lesson 7 exercise on Cam Instructor. So this is the page that you're going to be plugging in the values for lesson 7. There is a video for this on Cam Instructor. So I believe if you go to the mill under lesson 7, it is this video right here, the number 5, circular interpolation, absolute and incremental video. Okay.
So we've got a page to do, a video to watch, and 2 programs to write.
Yep. The video goes with the page. It actually walks you through that page if you need it. If you can do the page without the video, you don't have to watch the video if you feel confident in your answers. But the video, like I said, it kind of walks you through those and helps you complete the page. Okay, so you can go on there even just to check your answers. All right. Okay. Let me get your attention just real quick. I got one other thing I wrote down here I want to talk to you about. Over break, we had I had some discussions with the foundation, and we're working on some scholarship funds for the advanced program. So I don't know how many in here plan on doing the advanced CNC program at the tail end of your 2 years. Then you got the advanced, which will be back in the summer of what will that be, 2023 for us? Yeah, the summer of 2023. But basically, we've got a scholarship fund that we're working at to where we can give everybody a chance to apply for it. Everybody will get, if you apply for it and you're accepted into that program, you're going to get a little bit of scholarship. Okay, you'll get something. If you can keep your GPA above at 3.5, or by the time you graduate have your GPA to a 3.5, there's a chance to get a significant scholarship of up to $1,000. Okay, which is like 23% of what that costs. Okay, so, or 23. I don't know why I said an obscure number. 20%. It's like $5,000 to do that summer program. So it pays for 20% of it with that scholarship. It's basically $500 from an account we have, and then the foundation's going to do a matching amount. What that allows us to do is it lets us submit you to the Indiana Awards for Excellence Committee to win the Indiana Awards for Excellence recognition, which then that's why the university is willing to match the precision machining dollars that we're putting up. But you have to have a GPA of 3.5 or better. So if you want a chance at that extra money, maybe try to do a little better than the C average in math and English and in the other classes. Okay?
How do we apply for all of that?
It's right there at the end. Once we get to the end, everybody does the application. If you're doing the advanced program, everybody's going to be applying for that scholarship, I imagine, unless you're already on a full ride of some other type. So.
And that's through the university's scholarship application?
It's through our department. No, it's actually us. Yep. Okay.
So you'll get that to people.
Yes. Yeah.
Gotcha.
You got it. All right.